Corporate finance practice problem using Excel. We're going to be calculating the bond value, a bond that has semi-annual payments for multiple different rates having a rate change. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We're going to have the information on the left-hand side, using that information to populate into the blue area on the right-hand side, calculating price, but keeping into consideration that we have the semi-annual payment as opposed to annual payments, making it a bit more confusing. We will calculate this first to get back to basically the face value, having the market rate, which will be the same as the rate on the bond, and then we'll make a change to that, having the rate change for the market to the 8%, and then figure what the price will be at that point. So our information up top, we got the price or the face amount of the bond is going to be the 1,000. That's the face amount of the bond, not the price. The life is going to be 22 years, and the rate is going to be the 15% semi-annual payments. We're going to start off with a market rate that's 15% as well, imagining that we issued the bond. Basically, when we first issue the bond, we try to have the rate, of course, match the market rate so that we could basically sell it for the face amount. However, it's less intuitive that the face amount will be the 1,000 when we do the present value calculations for it. So let's prove that first. Then we'll make a change to say that time has passed. In this case, 5 years have passed. And then we're going to have a rate of the 8% down below for the market rate. Then calculating the price of the bond, where we're going to have a difference between the amount on the bond and the amount that we will have, the change resulting in a discount or premium. The fact that the rate is below the rate that would be on the bond means that people cannot find bonds that pay 15% elsewhere. Therefore, they're willing to pay more for this bond, our bond, and therefore we expect at that point the price to be higher than the 1,000. Not because 5 years had passed, but because in that 5-year time period, after that 5 years, the market rate now 8%, our bond 15%. Therefore, we can sell it typically at a premium. So let's do this first one first. We're going to take a look at this 15%. We're going to get back then, we expect to get back to the $1,000 price because we're using the same market rate as we are for the rate on the bond. We're going to have the present value of the annuity as well as the present value of one calculations. Annuity first. Here's the calculation. Remember to keep in mind the fact that it is semi-annual, making this calculation a bit more complex. So we have P times 1 minus 1 plus R to the negative N over R. P is going to be the 1,000 times the 15%, the rate on the bond, I should say, divided by 2. And then it's going to be times 1 minus 1 plus R, also 15%, this time being the market rate, however. And we're going to take that 15%, which is the yearly rate, divided by 2 to get the rate on the bond to the negative N. That's going to be the number of periods, which would be 22 years if annual, but semi-annual. Therefore, we'll times 2 on that one, divided by R, once again, rate of the bond, market rate. But we're going to take the 15 divided by 2. Let's break that out into our table over here. We're going to take the 1,000 times the 15%. That would be the amount of the payment if it was yearly. If I hit enter, that's what it would be yearly. Double clicking on that, I'm going to take that and divide it then by 2 because it's semi-annual. Therefore, 75 on the semi-annual payments. And there we have that. We'll add a couple pennies there. Then we're going to say the 1 minus 1 plus R, which is going to be the numerator. So we got 1. Then we're looking 1 plus R to the negative N. 1. R is going to be the market rate, which would be that 15%. But we're going to divide it by 2 because it's semi-annual now. Adding percents, number group, percent, decimals. Add a couple decimals, so 7.5%. Adding these two up, but first underlining, font group, underline. Trusty sum function, SUM, sum function, adding those two up. Then we're going to make it a percent number group, percentify, 108. Let's add a couple decimals to it, 107.5. We're going to take this to the power of the number of periods, which would be 22 if yearly, but multiplying that times 2 because they're semi-annual. We're talking 6-month periods or half-year periods here. Font group, underline. We're going to then take this to the outer column where we take the 107.5% to the power of shift 6, negative 44, and enter. Adding decimals, home tab, and numbers, decimalizing it. Underline, font, underline. Subtracting out to finally get to the numerator. 1 minus this number gives us the numerator. Number group, adding decimals again. And then we want the denominator, which is simply going to be R, which is the market rate 15 divided by 2, because it's the rate per period per 6 months. Number well, let's make it a percent and then add some decimals. That's how we should do it. And then font group and underline, and then we'll take the num divided by the denom. So here's the num divided by the denom. And then we'll add some decimals here, home tab, adding decimals once again, font group, underline, multiplying the outer column now, the payment, 75 a month times this amount, not a month, a 6 month, a period, a 6 month period. And let's add some pennies here, numbers. So there's the present value of the annuity. Then we need the present value of the one, which we think should get us to that $1,000. So we'll do that shortly. But before we do, let's calculate this a couple different ways. Let's break this annuity down into our table here, present value of one calculations. This gets much more complex, or longer at least, given the fact that we have semi-annual payments, because even though we have 22 years, which would be long enough, now we've got to multiply that times 2, 44 payments. But still easy to do with Excel because we have that autofill function. So let's go ahead and do it. So we're going to have then the payments. Let's make 1, 2, and then I'm going to select those and grab Phil's handle for autofill, dragging it down. We're driving it down. This is the auto part. Auto's driving it down. We're driving it in our auto, and then we're going to let it go and fill. There it fills. And then we're going to go to the home tab, alignment, and center. Then the payment, which we could pick up that 75, but let's recalculate it just so we remember how to do it here. It's going to be the 1,000 times the 15%, but that would be for a year, then divided by 2, because this is semi-annual or every 6 months. Present value calculation is going to be negative PV. Present value of 1 is what we're looking at. Shift 9, the rate, then is going to be the market rate of the 15, but we got to divide it by 2 because we're talking 6-month time periods, and that's for 12 months. And then we're going to say, comma, number of periods, we're just taking one period. That one period, though, not representing a year now, representing 6 months. Comma, comma, because it's not an annuity this time. Future values our payment, the 75, and enter. There's our starting point. Let's do it again. Payments are going to be the same. Why? Because it's an annuity, and that's what happened. That's what it means. That's what it means to be an annuity. If you want to be an annuity, that's what has to happen. So then we're going to say present value. The rate is going to be, once again, the 15% over here. I'm going to make that an absolute reference now by putting F4 on the keyboard, $ before the B and 9, and then divide that by 2, which we don't need to do any absolutizing to because that's going to be a hard-coded number. So that'll copy down just like it should. And then copy, we're going to take the number of periods, which is now 2, comma, comma, future value 75, and enter. So then the value we're ending up with is the 65 plus the 70. Let's go ahead and copy this down to 44 periods, selecting these 3 cells, putting our cursor on auto Phil's handle. So there's Phil's handle that we're taking, and we're dragging Phil's handle down. Auto is driving it. We're driving it all the way to 45 or 44 periods, and then letting go, and then there's the fill-in part of the autofill. So there's a 959 matching up to 958.50 over here, except there's no pennies. So there we have it once again. Now we could copy this down one more time and say, why don't we just present value 45 periods out? This is going to be 44 periods out. The 1,000, present value that too, and just get to the answer right then, right there. Let's go ahead and do that. Let's make this the 1,000, present valuing the 1,002. Bringing it back, it would only be worth $41 if we brought it all the way back. That gets us to the 1,000. Don't get these two 1,000s mixed up. That first 1,000 is what we are present valuing, it then being $41, which then added to the 959 for the present value of the annuity gets us to 1,000, the price, which of course is the same as the face amount due to the fact that the interest rates are the same. And that's our starting point. That's what we expected to happen, and what we expected to happen is exactly what indeed did happen, which is, that's good. So then we're going to say negative. Let's do this with an annuity formula the easy way. Present value, shift 9. The rate is the market rate, but then I got to divide it by 2, comma. Number of periods is going to be, now we're doing the annuity, so it would be the 22, but then I got to multiply it times 2 because it's really 44 periods, comma. And now it's an annuity, so we're going to have our annuity calculation. I didn't have the 2, so the rate divided by 2, and then the periods times 2, and then the payment, which is going to be, we'll do the calculation, the full calculation again. It's going to be this 1,000 times the rate on the bond, but then that would be yearly divided by 2. Divided by 2. Let's look at it one more time. That was kind of complicated. It looks complicated. That looks impressive. So that we're starting to be impressing people with this one, right? This one. So there's the rate. We got to divide it by 2. There's the number of periods. Multiply times 2. There's the payment, which was the, calculating the yearly payment, but then dividing it by 2. And once again, we get to the same value, 954.50, 958.50, 958.50. Okay, we won't do it with the tables because the tables become less applicable as we start to get more periods that are going to be involved. So you can still use the tables, but now we're getting far out into 48 periods due to the fact that they're semi-annual, and the more periods we have, the more difficult it is to use the tables. So if we were to use the tables, just remember you would have to make sure you get the proper periods, which would not be the 15%, but the 15 divided by 2, the 7.5, not 22 periods, but 44 periods. Okay, now let's do the present value of 1 again for that 1,000, bringing it back. That's going to be our present value formula here. Present value equals the future value. I'm going to say over 1 plus r to the n. Future value, the 1,000 at the end, divided by 1 plus r, which is going to be the 15% market rate divided by 2 to the number of periods, which is 22 periods, but multiplied times 2 because they're 6-month periods. So we then have the rate. We'll put that on the outside. That's going to be the 1,000. Then we have the 1 plus r to the n. So 1 r, now market rate at 15%, but divided by 2, therefore making it a percent number group, making it a percent, adding decimals, 7.5. Font group, underline, adding this up with the trusty sum function equals sum, S-U-M, of those two cells. Number group, making that a percent, the 108, a couple more decimals there, so it's 107.5. And then we're going to take that to the power of n. So this is going to be n periods, 22, but that's years, and we need 6-month periods, so we multiply times 2. We're talking 44 periods. Font group, underline, pulling this to the outside, the 107.5 to the power of shift 6, 44. And then let's add some decimals there, number group, and decimalize it. And then font group, and underline it. And then we'll do the num, 1,000 divided by the denom, that thing we just got to. And then we'll take the numbers and add a couple cents, the 41. Now, if we add that, that's the present value of the 1 to the annuity calculation we just got before, which is, I'm going to pick this up over here. We got that 958.50. We should add those up and get to, what should we get to again? 1,000. The face amount, 1,000, because the rates were the same. So we got that same 1,000 that we got to before when we did that running balance too. Same thing. That's exactly what we expected to happen, and that's indeed what didn't happen. We found the very thing that we were searching for. So now we're going to say negative present value. Let's do the annuity calculation again. We want to get, not the annuity, present value of 1. We want to get to that 41.50. So negative present value rate is going to be the market rate divided by 2, comma, number of periods is going to be the 22 times 2, comma, because it's not an annuity, but present value of 1, the future value, then the 1,000, giving us, once again, the 41.50. So there we have it. We've done it a couple different ways. Now, let's make a change. I'm going all the way back to the left, and now we're going to scroll down, and we're going to do the same thing, but this time there's been a change. And what has happened? 5 years have passed. The bond has served us well, but now we want to sell it. And now, because time has passed, the rates are not the change. The market has different expectations, those being 8%, and the rate on the bond is still 5%. So if we want to sell the bond at this point in time, then we're actually kind of at an advantage because we should be able to sell it at a premium at this point because the rate on the bond is higher than other people can get elsewhere. So let's do the same thing now, but the life is now 17 because it started at 22 minus the 5 years that had passed at the 17, and then the rate on the bond is still 15, but now the market rate is 8 here. So let's do the present value of the annuity, which is P times 1 minus 1 plus R to the negative N over R. P is the same. It's the 1,000 times the amount on the bond, 15%, divided by 2, because it's semi-annual still. 1 minus 1 plus R. R now the market rate, 8%, but that's yearly, divided by 2, 4% to the negative N, which now is 17, but that's years times 2, and then divided by R again, which is the market rate, 8% divided by 2. Okay, let's break that out in the table. Take a look at it in our table format. We've got the 1,000 times the 15 market, or the rate on the bond, divided by 2 because it's semi-annual. And there we have that, and that's the same. Then we have 1, I'm pulling into its own column. Now we're looking numerator 1 plus R to the negative N. 1, R, now market rate, change, 8%, divided by 2 because this is semi-annual. Numbers, percentify that. And then underline, numbers, underline, summing it up equals sum, shift 9. Where did that multiplication? Shift 9. And then numbers, making it a percent to the number of periods, which is negative 17, but semi-annual, so times 2, therefore 34. Then font, underline, taking this to the outer column, this is going to be equal to the 104 to the power of shift 6, 34 periods. Adding decimals, numbers, look like nothing was there, but there really is when we add the decimals. And then font group, underline. Then we're going to do the subtraction, get into the last component of the num or numerator, 1 minus that thing we just got to. And then numbers, adding some decimals here to make it a little bit more interesting. And then we have the denom, market rate, again, 8% divided by 2 because we're talking 6-month time periods. Number group, percentify, font group, underline, pulling this to the outer column, taking the num or numerator divided by the denom or denominator. And then we're going to say numbers group, adding decimals there, font group, underlining, and finally multiplication of the payment amount per 6 months times that thing we just got to, add a couple decimals, and there we have the value of the annuity portion. We then need to get the present value of 1 for the 1,000, but before we do, let's do this calculation a few more ways. Let's break this annuity down into present value of 1 calculations. That'll be fun. Let's do that. So we're going to say this is going to be 1, 2. I'm going to take these all the way down to 34 payments, 34 6-month periods by grabbing Phil's handle and dragging it down. We're driving it down with the auto now. The auto's driving it down. 34 payments, letting go. There's the fill part of the auto fill. And then we're going to go to the Home tab, alignment, and center it. Let's make the payment. Let's recalculate the payment again just so we know where that comes from. It's going to be the 1,000 times the 15%, the amount on the bond, divided by 2 because semi-annual. And then the present value is going to be negative PV, shift 9. Rate is going to be, let's calculate that again. That's going to be the market rate here divided by 2 because semi-annual, 6 months. And then the number of periods, 1 now, because we're just bringing this 1 payment back, comma, comma, not an annuity, 75, and enter. So we'll bring that one in, and then we'll just continue this process. Annuity payments the same because annuity, negative present value, shift 9, rate, once again, the 4% calculated at the market rate divided by 2. But before we do that, let's make it an absolute reference so we can copy it down, selecting F4 on the keyboard, $ before the B and 59, then divide by 2. 2 being a hard-coded number, nothing we need to do special. We don't need to make it absolute. It's just going to do exactly what it should when we copy it down. Number of periods is going to be 2 now, and then comma, comma, and the payment is the 75. So then after 2 periods, present valuing it back, 72 plus 69. Let's go ahead and then copy these down, selecting these 3 cells, putting our cursor on fill's handle of the autofill, and driving that down, driving it down with the auto, and then letting go for the fill. Auto, and then it fills. So there's the 1381, matching the 1380.84. But we have that last payment. So we could drag this down one more time. I could say, let's drag, that's why I have that other yellow box, in case you're wondering. We could drag it down one more time. It's also 34 periods out, but this is going to be the present value of the principal, the 1,000, the face amount of the bond that would be paid at the end, that 1,000 right there. If we present value it, it's now worth more because time has passed. It's closer to the current time point, 34 periods out rather than, I believe it was 44 before. So it's 269 plus the 1,381 would give us the value of the bond, which would be that 1,644. So that's what the price of the bond we're expecting is. It's much higher than the value of the bond, or the face value, the face amount of the 1,000, due to the interest rates being different, the rate on the market being less than the bond rate. So then let's calculate this again, this 1,380, using it with an annuity calculation in Excel, the easy way. Let's do it this way, the easy way, the Excel way, my way, present value. It's not really my way, but that's the way I would choose because it's the easy way. But I would say it's the Excel way. Anyway, rate is going to be the 8 divided by 2, 8 divided by 2, comma, number of periods, we're talking 17, but then times 2, comma, and then the payment, we're talking 1,000 times the market amount of the 15 divided by 2. That's what we're talking. We're talking. All right, and then if I go into that, this is what it looks like. It looks complicated, impressive formula, but not too bad. We're taking the rate divided by 2, so the rate matches the periods, which are the yearly periods times 2, because they're 6-month periods, and then the amount, which would be the bond times the face amount, but then divided by 2, because semi-annual. Okay, so now we got that number again that way. Now let's recalculate the 1,000 present value. The 1,000 present value using our present value of 1 formula, PV equals future value. I'm going to say over 1 plus R to the n, future value 1,000 over 1 plus R, which would now be the 8%, but then divided by 2, 4% to the power of n number of periods, which would be 17 if years, but then times 2 because semi-annual. So then we're going to say 1,000 here, and then we got the 1, I'll say 1 rate. Rate is going to be then the 8%, but then divided by 2, and then make it a percent number group, percentify, font, underline, trusty sum function, adding these 2 up, making it a percent number group with a percentification, and then we're taking this to the power of the number of periods, which would be 17, but then times 2, because semi-annual. Font group, underline, taking this to the outer column, that being the 104% to the power of shift 6, 34. Adding decimals, numbers group, decimalized, and then font group, underline, finally taking equals numerator, divided by the denominator, and then adding some pennies. So there we have that. Now, if we add that, that's the present value of the 1,000. If we add that to the present value of the annuity portion we got here, the payments, which was that 1,380.84, then we get the price at this point, which is that 1,644.39. That's what we got down here at the bottom of the annuity table too, 1,644 without the pennies. So that looks good. And that, of course, is greater than the face amount here due to the fact that the interest rate on the market rate is lower than the rate on the bond, so people are willing to pay a premium for it. Let's do this calculation again one more time. This time the easy way, the Excel way. This is going to be negative present value, shift 9, rate. Let's calculate the 8% over here, divided by 2, because semi-annual. divided by, or comma, number of periods, which is going to be 17 years, but times 2 because semi-annual, comma, comma, because not an annuity, but present value of 1. And then the future value is going to be the 1,000 because no explanation necessary, I think. So that's going to be the 263.55 once again.